Good morning, everyone. Today I will be discussing the growing intersection between artificial intelligence and healthcare and how leading institutions like Mayo Clinic are using advanced technologies to transform the way for the medical decisions are made. Traditionally, healthcare decisions relied mainly on standardized clinical protocols, and the physician's personal experience, often based on limited or localized data.
Hello everyone, my name is Mustafa Mahmoud Salam, and I will talk about how can Mayo Clinic overcome challenges related to data integration and ensure seamless analysis of diverse healthcare datasets. The first challenge it was resolving mismatched data formats. Firstly, we have faced a variety data formats used by different hospitals. For example, Hospital A used Epic EHR system with JSON format, and Hospital B uses Cerner with XML format. This makes a problem when running our programming analysis across systems. We solve this through FHIR, which is Fast Healthcare Interoperability Resources Standards, which convert all these different data into single JSON format. Our packages like Sparkler can read this single format directly and enable seamless analysis across multiple healthcare systems. Challenge number two, it was solving unit conversion and data quality issue. Another hard challenge, this challenge, it was hard because we dealt with mismatched data units. For example, Hospital A, they measure blood sugar as 120 milligram slash DL, and another hospital uses 6.7 mmol slash LM, another hospitals, and the other one they can simply use high in clinical notes, making analysis impossible. We at Mayo Clinic use Schema Visualizer AI tool, which automatically detects these variations and and gaps and suggests intelligent units, which can make analysis easy. Challenge number three, it was solving HIPAA limitations. This challenge was hard because it isn't allowed to transfer personal data of patient to another hospital, with violation carrying fines and imprisonment. So we implement federated learning architecture where each hospital trains our model locally on their own data, then share only model weights like three small numbers rather than patient data. Okay, let's move to challenge number four, which is making team coordination through various location easy. It isn't easy to make more than clinicians through different locations developing our script and validating the results. So we have to think out of the box, which make us use MCP, which is Model Context Protocol, which is workspace enable AI agents to securely access, read, and manipulate local or remote project data MCP workspace, allowing real-time collaboration features similar to Google Docs. Let's move to challenge number five. It was expanding data analysis. So we face the challenges of processing enormous data from multiple systems, which traditionally take months of manual hand-picked sample. There or our court visualizers from Project One uses AI to identify perfect patients group for studies in seconds instead of months. These tools successfully identified large number of patients across healthcare system for various studies and decreasing failure rate.
Now we will talk about the strategies used by Mayo Clinic to enhance interpretability. Imagine a doctor reviewing a patient case when an AI system suddenly shows high risk of cardiac event. The prediction might be accurate, but the doctor immediately asks why. If the system cannot explain its reasoning, trust quickly disappears. This is known as clinician trust gap. Institutions like Mayo Clinic are addressing this challenge by developing interpretable AI systems within analytics environments such as R programming language. This allowing doctors to understand how predictions are made, and to understand this approach, we can explore it through 5 key dimensions as the following. The first dimension is stakeholder perspective. Healthcare AI affects multiple stakeholders: physician, patient, data scientists, regulators. But physicians are the main users. When models behave like black box, doctors cannot understand or verify reasoning behind predictions. Explainable AI (XAI) methods such as shape or partial dependence analysis help solve this problem by showing how each variable contribution to a prediction. This allows physicians to evaluate AI recommendations rather than blindly accept them. For the interpretability, which is considered as a strategic capability, it is not just a technical features, it is a strategic capability. Without trust, clinicians will not adapt AI tools. Transparent model support, better clinical decision making, regularity compliance, stronger user trust. This is why organizations like Mayo Clinic invest in AI literacy program, helping doctors to understand how AI works and how to interpret model explanation. When it comes to cross-function integration, interpretable AI sits at the intersection of several fields: medicine, data science, ethics, regulation. Two approaches are commonly used. First, intrinsically interpretable model, such as regression model, which are simple and transparent. Second, post-hoc explanation method that explain complex model after they are trained. When the explanations are integrated into dashboard and are based workflow, clinicians and data scientists can review prediction together, making AI collaborative tools rather than mysterious systems. For the evidence and transparency, trust also requires clear documentation. One important tool is the model card, which works like a nutrition label for AI model. Model cards explain the purpose of the model, training data source, performance metrics, potential risks or bias. This transparency helps clinician, researchers, and regulators to evaluate whether an AI system should be used in real clinical settings. For critical thinking in model trade-off, in healthcare, AI decisions are not just about maximizing accuracy. Often there is a trade-off between model accuracy and model interpretability. Simple models may be easier to understand, while complex models may achieve higher predictive performance. The key question becomes, which model is appropriate for the clinical context? Responsible AI adoption requires balancing performance, transparency, and patient safety. This is all from my side, and now
So now we are going to the third question. How can the healthcare institution balance innovation with regulatory compliance when using the AI and R programming to analyze the sensitive patient data? The first one is we must look at the human element of this project. Implementing AI at my clinic isn't just about technology, it's about managing that needs of 7 keys of stakeholders, each with their own unique perspective. Um, Firstly, with the clinic, for our doctors, the priority is interpretability. They need to trust the AI suggestions to the patient life. And for the patient, they care about equity and privacy. If we're talking about the data scientists, their focus in innovation. They need the best R programming tools and high quality data to build accurate model. For the IT and the security, It's all about infrastructure. They ensure that the systems are stable and protective. For the executives in Mayo Clinic, they're looking about the ROI and the strategy. They want to see how the AI improve their Mayo Clinic reputation and operational efficiency. Now let's look at the critical decision. How should we store and handle this sensitive data? We compared two main architectures. On the right, we have a centralized data lake. This is the traditional way, putting all patient record in one single database. While it is fast and easy, one single breach could expose millions of patient records at once. For the five-step government, this is the third one. After choosing our architecture, we need a system to manage it. It's about five governance framework, the rules of the road for the AI at Mayo Clinic. Step number one is the AI review board. Before any project start, a team of ethical and legal experts must approve the AI model to ensure it meets our standard. Second step is to secure the sandboxes. We never use a real patient names for testing. We use to be de-identified data inside this isolated sandbox, so our researchers can experiment freely without any risk to privacy. The step number three is the MLOPs. Using the R packages like Rainy and Targets, we create a traceable history for every model. This makes our work fully auditable, which is a must for the healthcare regulation. Step number four is to monitoring. Once a model is alive, it is not set and forget. We use automated check to monitor the performance and the compliance of each day. Step number five is the dynamic regulatory alignment. The laws in the US, like the HIPAA, change, and our framework is designed to change with them, ensuring we are always be protected. To wrap everything up, we have like a 6 months clear roadmap to bring this strategy to life. In phase number one, during the first month and second month, we focus on foundation. We will form our AI review board and audit all current R scripts to find and fix any security gap. In phase number two, between the third month and the fourth month, we build the infrastructure. This involves deploying our isolated secure sandbox and setting up MLOP specific tools into targets. Finally, in the phase number three, by months the 5 and 6 months, we go live. We will launch our first fully compliant AI model and begin continuous monitoring through automated SLA. We will measure our success through two main KPIs. First, we aim for zero data breaches, ensuring patient is never broken. Secondly, we expect like 30% faster deployment of research model and getting life-saving tools to our doctors to be much quicker than before. This plan ensures that Mayo Clinic remain a leader in both medical innovation and patient safety.
Salam, and now I will talk about recent updates and emerging trends in Mayo Clinics. The updates, I will start with the first one. It was Nature Medicine publication. Mayo Clinic published discovery results from 3 MCP projects in Nature Medicine, and project 1 it was court visualizers, which identified large number of patients across 5 healthcare systems, and project number 2 achieved 92% accuracy predicting MCI to Alzheimer progression using PIGRO deep learning models in R, and project number 3 delivered 89% percentage accuracy for misprediction post-liver transplant. This result proves that MCP ability to merge AI and R across diverse healthcare datasets. Update number 2, it was a partnership with NVIDIA, which have created an AI platform called Monai for federated learning and accelerated R computing. The AI platform deal with 10 terabytes plus multi-model datasets as electronic health records or genomics, which is more faster than other infrastructures. The partnership allow clinical decision on time through dashboard during patient care. Update number 3, it was citizen development activity, and which Mayo Clinic launched citizen development activity where clinicians build AI model using our interface without writing codes, and more than 200 physicians invented predictive models for treatment and avoiding risks without science of data education, without even or being educated. This allow using AI and scientific research through clinical field. According to trends, the first one is merging multimodal data. Merging electronic health record as medical imaging, genomic sequencing, wearable device in single hour pipeline. And I will give you example of that. Predicting cancer return using CT scans plus patient lifestyle and genomics. Trend number 2, it was multi-agent AI and more than clinicians through different countries can handle and modify the same data and can select clinical trial patients and monitor them remotely. Trend number 3, it was Mayo Clinic platform insights. Mayo Clinic platform insights have 26 petabytes including 3 billion laboratory analysis and 6 billion medical image. Its purpose is to export enhanced AI solution to small hospitals at worldwide, and this transparency between developed and developing countries to be easy for small hospitals to find solution for patients at no time. And thanks all for listening to us.